This is a video tutorial on graphing quadratic equations. To graph any quadratic equations, there are 5 features you need to determine beforehand. Now, on my blog, I have also created a table that you can download that provides a written description of each of the steps I'm going to do here. This might be something good that you want to download, print out, and keep handy because it has a written description and an example. Now, the first example we're going to do starts out as a quadratic equation in factored form. Now, regardless of what form you're given for a quadratic equation, the first thing you want to do is rewrite it in both forms. So it's in quadratic form, I need to expand it. And the way that you expand it is by foiling, and we've all learned how to foil so far. So I've got y equals, my F in FOIL stands for first, so x times x is x squared. My outside is 5 times x, which is 5x. Inside is 3 times x, which is 3x, so 5x and 3x is 8x. And my last is 3 times 5, which is 15. So now I've rewritten both equations in factored and expanded form. Now I'm going to go ahead and find my first feature, which is the x-intercepts. Now remember, x-intercepts always occur when y is 0. So I have to ask myself, well, what would these two factors have to be to make y equals 0? So what number would I put in for x to make x plus 3 equals 0? And the answer is -3, because -3 plus 3 is 0. So my first x-intercept is the point -3, 0, and you always want to write this as a coordinate point. Now my second factor is x plus 5, so I have to ask myself, what would make x plus 5 equals 0? My answer is -5, because -5 plus 5 is 0. There are my two x-intercepts. Now I'm going to move on to my y-intercept. Now to get your y-intercept, you're going to use your expanded form. Y-intercepts happen when x is 0. So that means this x is 0, it goes away. This x is 0, so that goes away. And the only thing you're left with is 15. So my y-intercept is 15. You can also tell that just by looking at your c value in your expanded form, which is the number that's by itself. So my y-intercept is 0, 15. Now, your line of symmetry is the point that's always halfway between your x-intercepts. So I'm going to take my x-intercepts, and to determine what's halfway between them, I can add them up and divide by 2. So -3 plus -5 is -8, and -8 divided by 2 is -4. Now, since it's a line, you need to, or since it's a line, you need to write it as an equation. So you would write that x equals -4. So 3 down, 2 more to go. Your vertex. Your vertex is your maximum or your minimum point. And that always lands on your line of symmetry. And since my line of symmetry is x equals -4, I already know that my vertex, the x value of my vertex, has to be -4. I just need to find my y value. So to get my y value, I'm going to take that -4 and I'm going to use the factored form of my equation. I'm going to put -4 in for both x's so I can get y. So I've got y equals -4 plus 3 times -4 plus 5. Now I solve this. -4 plus 3 is -1. -4 plus 5 is +1. And -1 times 1 is -1. There's my y value. So that's my vertex. Lastly, I need to figure out, does it open up or down? So does it have a maximum or a minimum point? And to figure that out, you're going to use your expanded form. And here's how you do that. Look at your x squared. If x squared is positive, it's going to open up. So my x squared is positive, so it opens up. And here's how you remember that. If it's positive, it's happy, so it's going to be smiling. If that was a negative x squared, it would open down. It would be unhappy, it'd be having a frown. So this one is going to open up. Now that I have those 5 features, I'm going to go ahead and graph them. So my first feature, the x-intercepts are at -3, -5. So on my graph, I'm going to go ahead and plot -3, 0, -1, -2, -3, 0, -5, 0. My y-intercept was at 0, 15. So here's my y-axis. I'm going to plot 0, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 0, 15. My line of symmetry is at x equals -4. So I'm going to find where x is -4, which is right, -1, -2, -3, -4. Since it's a line of symmetry, I put a dashed line all the way through x equals -4, like so. And my last feature I have to graph is my vertex, -4, -1. So I plot the point, left 4, down 1. -4, -1. Here are my 4 points, and I know it's going to open up, get that smiley face, so I can go ahead and connect them. And there's my nice, beautiful parabola. Now, this equation started in factored form. Our second example is going to start in expanded form. But like I said before, regardless of what form you're starting in, the first thing you want to do is rewrite it in the other form. So this is an expanded. I'm going to rewrite it in factored, which means I need to get those parentheses. Now to do this, we've got to factor, but the good thing is we all know how to factor. So I'm going to start off and put my x's in. And I need to think of factors of 12 that could somehow give me 8. So I think of 12, I go, okay, I've got 1 and 12, I've got 2 and 6, and I've got 3 and 4. Which one can somehow give me 8? Well, it's got to be 2 and 6. Now I need a -8. So what signs do I need to use to get a -8? Well, that's going to be a minus and a minus, because -2 and -6 give me -8. So we're in good shape. We've got expanded, we've got factored form. Now I'm going to find my x-intercepts. Again, for x-intercepts, you always use factored form. So I need to figure out x-intercept is when y equals 0. So I need to figure out what would make the factor of x minus 2 equal to 0. Answer is 2, because 2 minus 2 would give me 0. So my first x-intercept is 2, 0. Now I look at my second factor. What would make x minus 6 equal to 0? And my answer is 6, because 6 minus 6 would give me 0. X-intercept's done. You can check it off. Y-intercept. Y-intercept, you always look at expanded form. And again, y-intercept is when my x's are 0. So if my x's are 0, the first term's gone, the second term's gone, and all I'm left with is my c value, the 12. So my y-intercept is 0, 12. And always remember, you want to write these as coordinate points, because that's what they are. 2 down, 3 to go. Line of symmetry. Line of symmetry is always halfway between your x-intercepts. So my x-intercepts were 2 and 6. To figure out what's halfway between them, I add them up, divide by 2. 2 plus 6 is 8. 8 divided by 2 is 4. And remember, line of symmetry, so you've got to write it, x equals 4. Just vertex is up next. Line of symmetry is on, or vertex is on your line of symmetry. So I already know my x value has to be 4. So 4 is done for my x. I just got to find my y. Again, to get your vertex, you're going to use factored form. So I'm going to plug 4 in for both x's. So I've got y equals 4 minus 2 times 4 minus 6. 4 minus 2 is 2. 4 minus 6 is negative 2, and 2 times negative 2 is negative 4. So there's my y value. Remember, there's that table I have on my blog that will show you, that explains exactly which form you use for which feature. So that can help you keep everything straight. Okay, last one, opens up or down. This one I'm going to use my expanded form. X squared is positive. That means I'm going to get a smiley face, so it's going to open up. So now I start graphing that I have all 5. X-intercepts first, 2, 0, 6, 0. Go over here, here's 2, 0, 1, 2, and then 6, 0, 3, 4, 5, 6, 0. There are my x-intercepts on my x-axis. Y-intercept is 0, 12. So on my y-axis, I'm going to plot the point 0, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y-intercept. Line of symmetry was x equals 4. So I find 4 on my x-axis, and I draw on that dashed line that's halfway between my x-intercepts. Vertex, 4, negative 4. Remember, it's going to be on your line of symmetry. So over 4, down 4, 1, 2, 3, 4. And it's going to open up, so I can go ahead and connect these. And I end up with a beautiful, beautiful parabola. And there it is. So again, these have been 2 examples of how to graph quadratic equations. If you need to rewind it and watch it again, go ahead. You can fast forward to the parts you need or rewind to the parts you need. And again, remember, there is this table you can look at that tells you exactly which form you want to use to get each feature. It's a good thing to print out. Thank you for watching this tutorial on graphing quadratic equations.